Okay, this video I'm going to be going over some techniques in using your graphics calculator. I have a function here, y equals the square root of x cubed minus 4x plus 4. So I'm going to start by graphing that, then I'll be addressing some questions that I have below. Alright, so go into menu, graph. Okay, now I've already set up this equation and I already have an appropriate window for this. Alright, so you notice there's a little funny bit here where it doesn't graph. We're going to come to that in a minute because that's going to cause us problems. Alright, so but otherwise I could even make this window a little bit larger. Let's have a look at a bit more X space, a bit more Y space. You can see here, okay, so we've got this graph going on here. So we don't need that extra space, but you can see basically the pattern's forming. And we don't have anything over here. There's a reason for that. It has to do with the square root. And it's going to cause us a few problems with some of the questions, particularly the first one. All right, now the x-intercept occurs when y equals 0. All right, so there's a few ways you can solve that on your graphics calculator, but we're going to discover it's not going to work in this particular occasion. A root of an equation is when the equation is equal to 0. All right, now it's going to return us a not found. All right, try it another way. Let's do a x count for when y equals 0. That doesn't work either. Now, if you know anything about cubics, you know they pass through the x-axis once. Now we have a square root around that, but still the square root of 0 should still be 0. The reason why this part of the calculator cannot solve this is because the way the calculator works. Your graphics calculator cannot solve this function for when y equals 0 because when the part inside the square root is negative, that returns an imaginary number. All right, that's another branch of mathematics. But what it basically means is your calculator can't deal with that. The way it solves, this is not an algebraic calculator, it's a graphics calculator. The way it solves for when something passes through the x-axis is it looks for a change of sign. But this is not going to happen because it will change from, if I move backwards in my function, it will change from positive, not to negative, but to imaginary. All right, so we can't do it that way. So we're going to go and look at another way. Okay, now we said that if the cubic was equal to 0, then y will be equal to 0 because the square root of 0 is still 0. So let's try this another way. I'm going to go to another section of my calculator called equations. Okay, now I'm going to solve a polynomial equation. This is a degree 3 polynomial because it's a cubic. All right. So let's put the coefficients. You notice you've got the cubic coefficients, ax cubed plus bx squared plus cx plus d equals 0. Let's put on the ones for this. So we have 1x cubed. There's no x squared term, so that's 0. Minus 4 for x and 4 for y. Okay. Now, you notice that we're solving for that equal to 0. All right. So the answer x cubed minus 4x plus 4 equals 0 at x equals minus 2.38. That is correct to 3 significant figures. All right. So I couldn't solve it in the graph mode, but I was able to solve when the inside cubic was equal to 0. Okay, so let's go back to our function. Let's have a look at our stationary points. All right. So you may be asked to find stationary points. You can solve them with calculus, but if we want to state to 3 significant figures, all we have to do is find the values. All right, so we've got a stationary point here, and we've got one here. So let's bring that up a bit more. So we have a local max and a local min. And those are the only two. So Now, the calculator will solve for stationary points max and min. It does not solve for stationary points of inflection, but we'll deal with how we can solve for inflections in the next part. But for now, you can solve for the local maximum by pressing gsolve maximum. Okay, and we've got the coordinates for that. So the stationary point occurs, the first one, the local max, occurs at minus 1.15 and 2.66. Okay, the local min all right, now that, sorry, it's out of the camera range. So what I did to solve for local min, gsolve min. Okay, that occurs at x equals 1.15, and just three significant figures. That'll be 0.960. So that's three significant figures. Okay, three significant figures both times. Now, the coordinates for the point of inflection, you don't have a direct way to solve for inflections on here for the function. But we know there's an inflection point if we get rid of the, just graph the function. And we're just going to zoom in a bit more. I'm just going to change the window again. Change it back to the settings I had, which is about 4. Okay. So you notice there's a concave and then a convex part. So there must be an inflection somewhere in here. Okay. I can't solve for that directly. With the trace function, I can actually trace. I can look at the derivative and what it's doing. So we have, all right, we have the derivative near 0 here. So if you look, it's getting more and more negative. All right, so we're getting more and more negative. Our slope is becoming more and more negative, and it should, okay, more and more negative. There we go. See, then it's going, all right, so that was slope of minus 1.189, so 1.119, minus 1.121, minus 1.12, and then you see the slope is getting less steep, so we have a less negative slope. So let's go back to where that changed. So there's a maximum. That is actually close to where the slope is steepest. So that's not precise. That's just using the trace function. We'll show you how to do it in the exact form. All right. So this is where the gradient is steepest. So what we're going to do is we're going to graph the gradient function. And what that will do is we'll find it's going to be a local minimum of the gradient function. All right. Now let's go and find out how do we do that. All right. So how do you graph the first derivative of this function? Press options, calc, dy by dx. Okay, dy by dx of now y1. You have to click on that y there. So that's that y and then just the number 1. Okay, and over here, we're not going to find the derivative at a particular value. We're going to solve it for all values, and we're going to use the variable key here. So that's x. All right. Now, the windows will not be correct, but we'll have a quick look at it, and then we'll adjust the windows. You notice it's coming down. Yeah, we can't see the bottom. You will be able to solve for it, but we're going to get a little bit more negative space. We'll give it a minus, I think we just need a minus 1.5. Will do. Now, you notice that where this had the steepest negative gradient. This one has a local minimum, and that's what we're going to solve for. G-solve minimum for, not for y1, go across, go down actually on your cursor's keys. Yes, we're going to be solving for the minimum of the second function, y2 equals dy by dx of y1. All right. This will take a bit of time because it hasn't actually done any algebra. It's gone and crunched these numbers a long way, so this does take a lot of time. So you just wait for that for a moment. All right, so you notice that we got a number here. Now it's actually solved for it. This number here is the x-coordinate for the local minimum of this derivative function. Now that will coincide with the inflection point here. The y value is not the coordinate here, so we need to write down this number, and we're going to find out what the other value actually is. All right, so the coordinate of the inflection point, we'll take the x value down, which was 0.4193. All right, I'm going to remember the 3 because I only need to write the answer to 3 different figures. What I'm going to do now is do trace. I'll bring this up. I actually want to find the y coordinate because the y coordinate I had down there was the y coordinate of the derivative, which is basically the value of the slope, not the value of where the inflection point occurs. So I'll do trace, and I can type in 0.419. Okay. Yep, that was basically where I thought it would be. Okay, so 419, and the other part of the chord is 1.55, so 3 distinct figures. Okay, so that's there. So we've actually gone and found the inflection point using this gravity's calculator. Okay, those are all the major skills I wanted to go through in this video. So try these out for yourself and see how you go.